Hello students, I welcome you for the last session of Mason's-Gain formula. So in this Mason's-Gain formula session, we are going to learn with respect to what I can say the block diagram reduction, right? So that is why block diagram reduction and Mason's-Gain formula. So why the topic say block diagram reduction has come in Mason's-Gain formula because so we have an other type of question that is say type C question wherein you are supposed to solve the block diagram. That is, you are going to reduce the block diagram in the form of signal flow graph, right? So whatever the block diagram representation is given for you, you are supposed to bring down that to a signal that is a signal flow graph diagram, right? This is what is one thing you are supposed to do, and then next what you're supposed to do. Further, there are some set of rules and regulations, right? So you know that in a signal flow graph we have a nodes, a forward path and feedback path and many more you have, right? You know what are all the terminologies that is present in signal flow graph, right? Yes, you know what are all the terminologies that's present in signal flow graph, that is source node, sink node, chain node, forward path and feedback loop, as well as their self loop path gain, dummy node, non-touching loops, and you have say loop gain. So all these are present for you, the components of signal flow graph, and you're supposed to meet all the components in the signal flow graph when you reduce the block diagram to signal flow graph. So now before that, let us understand what are the sets of rules and regulations that you have to follow when you convert a block diagram to a signal flow graph, right? That is what is one thing you're supposed to understand first. If you don't understand that, then it is like you can't even solve the problems, right? So these kinds of problems are also asked in the exam. So I'll teach you only one problem wherein you can solve all the other problems without fail, right? The same for what I can say the given. So ಈ ನಾಲ್ಕು ಏನ್ ಸ್ಟೆಪ್ ಕೊಟ್ಟಿದ್ದಾರೆ. So ಈ ನಾಲ್ಕು ಸ್ಟೆಪ್ ಅನ್ನು ನಾವು ಉಪಯೋಗಿಸಿಕೊಂಡು ಮಾಡೋಣ. Okay, yeah. So here now we can see name all the summing points and takeoff point in the block diagram. So it is in the sense you can just name it or leave it. It's according to your wish. So name ಮಾಡ್ತೀರಾ. I mean you're going to name that. And second one is represent each summing and takeoff point by a separate node in signal flow graph. So how is the node in the signal flow graph? Say it is represented by a circle. ರೈಟ್ ನೀವೇನ್ ಮಾಡ್ತೀರಾ ಅಂದ್ರೆ ಸಮ್ಮಿಂಗ್ ಪಾಯಿಂಟ್ ನ ಟೇಕ್ ಆಫ್ ಪಾಯಿಂಟ್ ಅನ್ನ ನೀವು ನೋಟ್ಸ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀರಾ. So whatever the summing point and take off point that you have in a block diagram, say those are converted to nodes in the case of signal flow graph, right? The equivalent of that what I can say the summing point as well as the take off point in the signal flow graph is say node, right? Yeah. And third one, connect them by the branches instead of blocks, right? You know how the summing points are connected by blocks and takeoff points are connected by blocks, but here you're going to connect them by the branches itself, right? Instead of blocks, you're going to connect it by branches and indicating the block transfer function as the gains of corresponding branches. So the transfer functions of the blocks are the gains of the corresponding branches, right? That is what is one important thing. And you need to know this. The transfer functions of the block are the gains of the corresponding branches, right? Yeah. So, and then show the input and output nodes separately if required to complete a signal flow graph. So, you can show the input and output nodes separately. It's according to the given okay, if required, right? If it is required, you're supposed to do. So, here you're supposed to follow these two important things. I'm sorry, just a minute. Here I am supposed to follow these two important things without fail so that you can easily do the problem, right? Naming in the sense it's up to you that you're supposed to name or it's not up to like it's not up, it's up to you, I'm sorry. So yes students, and this is the diagram with respect to the given question. So the question states that so obtain the transfer function for the block diagram shown in the figure using Mason's-Gain formula. So this is already I have written it before while I was practicing, that is a few years ago, but neglect this and I'll mark it here. Neglect this and please only look at the diagram, okay? And according to the diagram, say so there are how many summing points and how many takeoff points, let us see, because all the summing points and the takeoff points are to be converted to nodes, right? The equivalent and signal flow graph was say nodes, right? Yeah. So here one, this one, this one, and whatever the ones which are highlighted in black. See, this is one is highlighted in black, and this one is highlighted in black, and this one is highlighted in black. Say all the three are what? All the three are said to be our takeoff points, right? There are three summation points as well as three takeoff points, and all the three summation points and takeoff points say they are converted to nodes, or they are their equivalent with respect to signal flow graph say nodes, right? So now let's start doing that. So here you are supposed to, or I can say, convert the blocks into arrows. So these are all the blocks, right? There was a G1 block, G2 block and G3 block. So those are written in terms of arrows, right? Arrows, that is forward arrows only, because they are moving in forward directions, right? Yeah. And here in between G1 and G2 say there is one summation point, wherein that summation point is converted to node over here, and in between G2 and G3 say there is one summation point over here, and that summation point is to be converted to nodes, right? And here also there is one summation point before G1 say that has been written as node over here, that is summation point number 3, and your takeoff point that has been present after G3 is written as nodes, and your takeoff point that is present before H1 is also written as node, and your takeoff point that's present before H2 is also written as nodes, right? There are how many nodes? 6 nodes, and 3 nodes are of summation points and 3 nodes are of takeoff points, right? Yeah. And now see here, and you can see that in between G1 and G2 there was a summation point which been converted to node, and from that node you are going to connect it to H1. So that is, see here, the summation in between G1 and G2 there is summation. That summation is connected before H1. Right, so that is why you are supposed to connect it before H1, and this is how you are supposed to do. How the connection is present, you are going to do the same connection, right? Instead of block, you're going to connect it by branches. That is what we have done. These are all branches, right? Yeah. And the summation point in between G2 and G3 that is connected before H2, or I can say it's in between H3 and H2. So therefore you're supposed to write it over here, right? And this arrow marks are reverse arrow marks, right? Yeah. Okay. And reverse arrow marks, that is, you're going to write in terms of branches. These blocks are written in terms of branches, and this is a what I can say, the reverse direction, right? Yeah, reverse direction, or I can say the left direction, right? Okay. So this is what is the diagram, and here one more thing to tell, let's start. So here is -1 and -1 present, and what's that -1? That -1 is saying nothing but, so here you can see that connect them by the branches instead of blocks. That is, you're going to connect all the required blocks by the branches, right? And then you're supposed to indicate the block transfer functions as the gain of corresponding branches. So block transfer functions are, say, the gain of corresponding branches, and this gain is written to be as this -1 and -1 respectively, right? So this is what is the thing. Okay, and this is what is the complete diagram. So how to write a diagram? ಏನೇನ್ ಮಾಡಬೇಕು ನಾವು ಡ್ರಾಯಿಂಗ್ ಅಲ್ಲಿ ನೀವು ಫಸ್ಟ್ ಒಂದು ಟೇಕ್ ಆಫ್ ಪಾಯಿಂಟ್ ಮತ್ತೆ ಸಮ್ಮಿಂಗ್ ಪಾಯಿಂಟ್ ಎಲ್ಲ ನೋಟ್ಸ್ ಅಂತ ಮೆನ್ಷನ್ ಮಾಡ್ತೀರಾ. ಆಮೇಲೆ ಯಾವುದೇ ಬ್ಲಾಕ್ಸ್ ಇದ್ರೂ ಸಹಿತವಾಗಿ, ಸೊ ದೀಸ್ ಬ್ಲಾಕ್ಸ್ ಆರ್ ರಿಟನ್ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ arrows and you are going to write the block name there, right? And then here also you are supposed to in the case of H1, H2, H3 also you are supposed to, what I can say, that is, write the arrow mark, and on the top of arrow mark you are supposed to write the block name, right? This is what is you are supposed to do, students. And then hello students, I welcome you for the last session of Mason's-Gain formula. So in this Mason's-Gain formula session we are going to learn with, yeah, and here there is only one forward path, so there is no what I can say other forward path, right? So everything is going in opposite direction. Only G1, G2 and G3 are moving in forward direction. That is why T1 is equal to G1, G2 and G3, right? Yeah. And then the individual loop gains are, say, that is nothing but L1 is equal to minus G2 G3 H1, that is this. So this is minus G2 G3 and H1, just a minute, yeah, and H1 and minus 1, okay, yeah, and this is what I can say, my L2 say nothing but minus G1 G2 G3 H1 H2 H3, that is this whole part, right, this whole part, and then what, it is nothing but L3 is equal to minus G3 H1 and H2. So this G3, this H1 and this H2 and minus 1 like this, right? Yeah. So this is what is one important thing, and here the first one is nothing but this G2, G3, this H1 as well as 1, and the last one is say nothing but that is G3, H1 and H2, and it's going like this, right? So this is what is the one he has written already in detail here, right? So I'm going to do the session in a simple manner because this is very much simple, right? Yeah, okay. And now here it's nothing but there is no combination of non-touching loops because all the loops are touching to each other, right? L1 is touching to each other. See here, there is a presence of G3, G3 and G3. There are same terminologies in all the three individual feedback loops, then they are touching to each other because this G3 and this G3 they get touched to each other. So that is why I can say that there is no combination of non-touching loops, right? And so therefore it is nothing but delta is equal to, that is 1 minus L1, 1 minus L1, L2 and L3, that is 1 minus L1 plus L2 plus L3, you know this, and here it is nothing but since all the loops are touching to T1 say, so delta 1 is 1, right? That's all the loops are touching to T1 because T1 is nothing but G1, G2, G3 and all the others also have G1, G2 and G3, so therefore they are touching to each other and that is why delta 1 is 1. And then now if I consider the C of S by R of S is nothing but T1 delta 1 by delta, which is nothing but G1, G2, G3 divided by 1 plus G2, G3, H1, that is the very first one which is L1, and this is G3, H1, H2, and this is G1, G2, G3, H1, H2, H3, which is nothing but L3, right? So this is what is for today's problem, and please do watch this without fail. And a very small clarification, there are takeoff points. So takeoff points are nothing but which is rounded in the black marker. So this is rounded in black, which is takeoff point, this is takeoff point and this is takeoff point. So there are 3 takeoff points together as well as 3 summing points together, wherein they are going to be replaced by the nodes in the case of what? The case of signal flow graph, as well as you are going to what I can say, you're going to connect it to branch, you're going to what I can say, that is connect them by the branches, and you're going to indicate the block diagram transfer functions as the gain of the corresponding branches, that is this, right? This is the gain of the corresponding branches, and then you're supposed to start solving like how you solve the signal flow graph, right? So this is what I was about to tell you, and please do see that there are takeoff points also. If I have told anything wrong, I am so sorry, and it's a takeoff points are present, and I've highlighted the takeoff point in the blue color, and please do see that, and those takeoff points are highlighted on black pointer, right? This is one, this is one, and this is one, right? So this is what is I was about to tell you, students, and this is what is the end of your module 1, module 3, and from tomorrow we are gonna see with respect to module number 4 and time.